competitive examination taken by 1 million students every year in India. It is for jobs in the government of India and entry to higher level education institutions. This is a question from the February 2016 paper on the theory of computation. So here is the problem. GATE 2016 paper 1 question 44, computer science and information technology. It's a multiple choice question on Oracle machines and many one reducibility. It's a multiple choice question. Straight away we know there are 4 choices. 3 choices are wrong and 1 choice is correct. The examiner guarantees this. Here is the problem, question 44. X is a recursive language. Y is a recursively enumerable or RE language. Y is not recursive. W and Z are 2 languages such that Y complement is a complement of a RE language, which cannot be RE, reduces to W. And Z is another language, reduces to X complement. X is RE, so X complement is RE. Now we know the recursive languages are close to the union, intersection, and complement. So if X is going to be recursive, X complement is recursive, Z must be recursive. So Z and X must be recursive. Now we look at other one, W. It depends upon Y. Y is RE, but it's not recursive. So Y complement cannot be RE. Y complement requires a hypercomputer or Oracle machine. Y complement reduces to W. So W, Y complement require Oracle machines. Z, X and X complement require ordinary Turing machine which alter all inputs. Z, X and X complement are recursive. Y complement and W are not recursively enumerable. Y is recursively enumerable. Now we have 4 choices, A, B, C and D. 1 of them is correct, 3 of them are wrong. First of all, we have determined as Z reduces to X complement and X is said to be recursive, Z must be recursive. The answer must be Z is recursive. That gives me only choice A or choice C. Now it depends upon W the answer. Y complement reduces to W. Y complement requires a hypercomputer. W also requires a hypercomputer. So W is not recursively enumerable. So C seems to be the answer. If C is the answer, A, B, and C, D must be wrong. Now, let us study it in detail. The recursive sets are closed and a complement. How do we know this? A recursive set is accepted for a halting Turing machine. If we interchange the accepting and non-accepting states in principle of the halting Turing machine, we accept the complement. So we say the recursive sets are closed and a complement. Now we are told Z, for example, reduces to X complement. X is a recursive language. Its complement, therefore, is recursive. As X is recursive, its complement is recursive, and so Z must be recursive. So Z is also not only recursive, recursively enumerable. But choice D says Z is not recursive. So choice D can be ruled out as being a candidate for the answer. Now, X is recursive, complement is recursive, Z must be recursive. Z is both recursive and RE. Choice D is ruled out. Let us consider Y. Y is recursively enumerable, but not recursive. So let us say it represents a halting problem. Its complement can be taken care of by an Oracle machine. This is called a hypercomputer. W cannot be recursively enumerable because W is obtained from reduction for Y complement. So we find that W cannot be RE. So W is not RE and Z is recursive. So C is going to be the answer. Since C is true, the examiner guarantees A, B and D are false. So the answer is C. End of the presentation. Thank you for your attention.